Hello everybody, welcome to General Physics 2 once again. The purpose of this discussion is to introduce you sort of to the big picture of how I structured this course and let you know a little bit about how I think about teaching and learning physics. Much of this information is also found in the course syllabus, so I hope you take the opportunity to read the syllabus and reach out with any questions that you have about this. So first of all, the first time that I got to teach physics, which was back in the late 1990s, which seems like a long time ago now, my students told me at the end of the course that there were two words that I used over and over and over again when I was discussing physics, and those words were intuitive and trivial. And I have since tried to scrub those from my vocabulary when I'm teaching a physics course. Because what one has known for a while may seem intuitive to one, right? But it's not intuitive to somebody who's learning it for the first time. And you may have found when you took General Physics 1 that there were some things in physics that naturally made sense and were intuitive, and there are others that seemingly were quite counterintuitive. And we'll probably run into those same kinds of things here in General Physics 2. Second thing would be trivial. None of these things are actually trivial, and again, it can take a lot of work to develop the problem-solving skills and the mindset to approach a physics problem. So actually, I try to think about this course from a different perspective now, and that is that learning physics is difficult for most of us. Again, I can easily fool myself because I've been doing this for 25 years, but yeah, for the first time, learning physics is difficult. And those of you that are teachers that work with students probably know this as well. It's not the easiest thing to present to students. A second philosophical approach is that learning physics simply by listening to somebody give a lecture about physics and then taking a test on physics and repeat is not a very effective way to learn physics. It may be effective in other disciplines, but physics, at least the research that folks have done on the teaching and learning of physics, suggests that most people learn physics much better if they can do physics in some way. Now that might be doing a laboratory experiment. That might be doing a series of conceptual questions in a workbook. It might be solving problems. It might be engaging others in conversation about physics. Those kinds of things are helpful in people learning the ideas of physics. And so when I teach this course live, we do a lot of small group activities where we're working on lab experiments or we're working on workbook exercises. Clearly, that is going to be a challenge with an online-only course. And if you would prefer to do the activities all on your own, that is fine. The course is scheduled asynchronously, meaning we are not all meeting at the same time in the same classroom. But if you would like to, I would encourage you to reach out to others and form collaborative groups to work together on problem sets, workbook exercises, labs if you like. And so there's an opportunity in the introductions assignment on the forum to let us know if you would like to work with others, and then hopefully that will spur some of you on to form some groups or some partnerships. What do you need for this course? Well, now we've partnered with the UNI bookstore to offer what they're calling these inclusive access packages. And so it seems like a good deal on our end. Students get Mastering Physics and the full electronic textbook for a price that is on par, I think, with what just Mastering Physics used to be in previous iterations of the course. So this will give you electronic access to the full book, which is good because the way that we've broken down the topics in General Physics 1 and General Physics 2, we actually hit a couple of things in General Physics 2 that come out of the chapters that are bundled as Volume 1 from the textbook publisher. So we're on the 4th edition of the textbook for this particular one. That doesn't really matter too much, but if you have this access electronically, you'll have the latest version of the book. We also use, and this is not available electronically, the College Physics Workbook, and it is full of exercises that line up with the content of each of the sections that are in the textbook. I think these are actually very useful for helping to learn the material, and so we will assign most of the workbook sections for the chapters that we go through in the textbook. Those get graded for you completing them only, not whether you're right or wrong on those, as it's supposed to be practice with the material. Most people find it handy to have a calculator as well that has trigonometric functions. You're going to be doing this online. You have your computer, so feel free to use your computer calculator, your phone, a standard calculator, what have you. But for most of us, doing things like calculating the sine of 42 degrees in our head is not something that we would relish. So how do I structure this particular course? Well, we actually start each learning cycle, and there are learning cycles within each unit, several of them, with an exploration or a modeling lab. By an exploration lab, I mean we're just exploring. We are playing around with simple materials and trying to see if there is a certain set of behaviors, or modeling labs where you actually are collecting quantitative data. Clearly, in the online version of this course, you won't be doing it with hands-on equipment. I can't give you magnets to play around with, but you might have magnets on your refrigerator at home. So very often we're going to use either a simulator or video of me actually conducting the experiment that you can watch and use to collect the data. So in a modeling lab, when you have a quantitative set of data, you then produce a graph of one variable as a function of another, and you try to look for mathematical relationships that relate the two. Following labs, which I actually use to introduce the unit to give you some hands-on experience with the material, we do one or the other or both of reading assignments or watching online lectures. Some people find reading a physics textbook helpful. Other people get through physics courses and never read a physics textbook. But I, in the course schedule, have put the appropriate sections within the night text there, as well as given you links to online lectures where I'm talking about the same material. So I would encourage you for the first couple of times to do both and see which one you prefer, if either. Then from there on, you might do one or the other, depending on which one you find to be more helpful. After we're done with getting introduced to the material through a lecture or a reading assignment, that's the time where we go back and do the workbook exercises. Again, I would highly encourage you, if it's a possibility, to form a partnership or a group with others online to work through the workbook activities in here. Then we do some in class. We would call this group problem solving. Again, if you can form a group, that's a great place to do it. But I give you a handful of practice problems about that concept and work through it. I've posted videos of me working through those problems. And so the ideal would be you solve the problem. And then if you need to check your answer, you can watch the video and watch my discussion of how I approach that particular problem. Finally, after that, you have some problem sets, and these problem sets are delivered through Mastering Physics. There are links to the Mastering Physics problem sets embedded within our Blackboard page. And then we start this process over again. And again, there are 2 to 5 of these cycles within each of our content units within the course. There's a course schedule, and you can find this link on Blackboard. It doesn't have a set date for many of these things. Anything that's an assignment that you're getting a grade for does have an associated due date. I would highly recommend that you try to get things done before the due dates if possible, because in many of these units I've put the due dates the last feasible time to do this. And if you wait till the last minute to do all of these assignments, you may find yourself in a situation where you got a lot of stuff to do in a very few number of days. So this just tells you the order of activities. So for example, in this course introduction module, we're doing things like watching this video to introduce ourselves to general physics and reading the syllabus for the course. There's a syllabus quiz to take after that, as well as 2 conceptual pre-tests, one of which is focused on your scientific reasoning skills, and one of which is focused on electricity and magnetism, which you may not know anything about right now, and that's perfectly okay. I'm just curious to know what you know before the class and after the class, so I can use it to measure the growth of understanding in this course. There are then 4 main content units, the first of which is on electrostatics. So you can see, for example, it starts with a lab on electric charge, and it lines up with content in chapters 20 and 21 in the textbook. Then you can either read the first 3 sections of chapter 20 or watch my lecture on electric charge. Following that, we're going to do the first 3 exercises in the workbook, or first 3 sections of chapter 20, rather, of exercises in the workbook. Practice some problem solving with Coulomb's law, do problem set 1, and then start the next learning cycle within this unit. And so when each unit ends, the very last thing is to take the unit test. And you'll note in the syllabus that there are dates where those tests become available and final dates when they have to be completed by. So pay attention to those syllabus deadlines. Speaking of those unit exams, they typically consist of 4 big problems, 2 of which are called, numerical problems, which allow you to demonstrate your quantitative problem solving skills. So can you use the formulas and the values and the numbers and things to solve a problem quantitatively? 2 of them are more conceptual in nature, so they are modeled more on the kinds of exercises you are going to see in the student workbook. Can you do things like rank things in order from greatest to least, and things of that nature? And then I always put a few multiple choice questions on each test. Some of you are taking this class in preparation for having physics on an MCAT or some upcoming professional exam. And so it's good to practice seeing multiple choice physics questions for that purpose. You are, in the regular form of this class, asked to take an exam with only having one reference sheet of whatever notes you've put together in prior to the exam. And even though when we offered this online in previous semesters, if you chose to not come and take the test in person, you had to get somebody to proctor the exam for you. Well, there's obviously a different world that we're all operating in, and due to some distancing restrictions, I can't require you to go take a test with any proctor anywhere. So these tests are going to be delivered simply on the honor system. You're asked to still take the test with reference to a single reference sheet, closed book, closed notes, closed references, but how you proceed with that is obviously up to you. After each unit exam, there is an opportunity to take a makeup exam if you did not do as well on the first iteration of the exam as you would like. And so please see the syllabus for the policies regarding the makeup exams. In this course, your grades are determined by a number of class activities. You get 5% of your course grade just for taking a series of pre-tests and post-tests and syllabus quizzes and the like, and completing those things. You get full credit just for taking the pre-tests and post-tests, by the way, but I hope you will give them your best shot because they help me know what you know or what you don't know. There are problem sets in this class. They're again delivered through Mastering Physics. They're 15% of the grade, and there are 15 of the problem sets, so each one is 1% of the grade. It is theoretically possible to pass this class without doing any homework, but it is not advised, as the homework gives you the practice that you need to be successful on the exams. 5% of your grade is for the workbooks. Again, I'm checking those for the fact that you completed the assigned sections only, not whether you answered the questions correctly or incorrectly. But again, I would hope that you would put effort into those. Those, again, are providing you with practice needed to be successful on the exams and to learn the content. 15% of your grade is assigned to each of the first 3 unit exams, so that's collectively 45% of your grade. And then the final exam is a little bit bigger. It is 20% of your overall grade. Finally, there are lab reports. So each unit has, anywhere from 3 to 5 different lab activities within it. Some of them are exploration in nature, where you're just messing around with a simulator to try to understand some phenomena. But some of them involve quantitative data collection, where you get a set of numbers and you can produce a graph and the like. And so for each unit, you need to write one lab report for one of the quantitative labs within that unit. And there are always at least 2 choices to decide between. And so collectively, you have to turn in 4 lab reports over the course of this class. So that's your 100%, and that's what makes up your grade that gets calculated in the Blackboard gradebook. And you should be able to observe as you go along and see how you're doing grade-wise as you go through the course. Obviously, because this is an online course and you got to this video through the link on Blackboard, we are using Blackboard to deliver all of the course materials. In fact, now we even have Mastering Physics links embedded within Blackboard, so you should be able to use Blackboard as your starting point for all the class activities. We deliver the pre-tests and post-tests through here. Any sort of handouts for the lab are there. You'll notice if you look at the units, there are in-person online versions of the labs. For this semester, we will obviously be using the online versions. There's links to recorded lectures. Group problem solving sets are available there, as well as my video walkthroughs of the solutions to those. And the homework assignments are linked there, and after the deadline for the homework, you should be able to also go and see the solutions to those on Pearson's mastering site if you would like to do so. Finally, a word about these conceptual pretests. They are based on research into student understanding. In physics, there are a lot of things that people have a difficult time understanding for one reason or another. And so these tests are designed to help instructors know what things people know and what things they struggle with, which are sometimes called misconceptions. They are used to help me gauge how effective this course is. And so if I see for several iterations of the course that we are doing particularly low on, let's say, the concept of electric potential, that might encourage me as an instructor to go back and look at that part of the course and say, okay, what can we do differently to help people learn this concept of electric potential better than we are currently doing so? So you shouldn't know the answers to the pretest on electricity and magnetism. The scientific reasoning one is more broad and should be stuff that you kind of understand by this point in your scientific career, but all of these tests are ungraded. It's my hope, however, that you'll give them your best effort because, again, I'm using them to try to get a window into what the students in this class do and don't learn as they participate in this course. So again, you can see how you did on those in Blackboard. The score should show up in the grade book, but the only grade that matters is the completion grade, which is the one that factors into calculating your course grade here. So that's it for an introduction to this course. I will again be in the Zoom room from 10 to noon, Monday through Friday every day. I hope you'll pop in and say hi, ask any questions that you have, as well as use that time or other scheduled time to work on assignments, workbooks, and whatever. Obviously, the hope is that you don't feel like I have to learn this physics in a vacuum with nobody helping me. The hope is, in fact, that we can work together using the technology that's available to us. And for those of you that want to, we can form collaborations in groups and get through this next 6 weeks successfully. Good luck, everybody, and let me know if you have any questions.